With our previous video, we have discussed some of the major energy metabolisms the body uses to generate energy for everyday activity. Now in real life, all of the energy pathways, either aerobic or anaerobic, are actually overlapping a lot of times with one another across different cells and even regions to provide you energy. Particularly, the TCA and ETC cycles are going non-stop somewhere around the corners of your body right now. It is because even the most essential bodily functions like the liver, stomach, immune system, and so on, they all need constant energy. Anaerobic metabolism serves as a secondary energy system when oxygen is presented for those vital organs and cells. This is why it is called aerobic respiration. You and your cells have to breathe, or else you all end up in here. Anaerobic metabolism is preferably used by muscle cells to get energy from. However, not all muscle cells are equal. There are slow twist muscle fiber and fast twist muscle fiber. Slow twist fiber is type 1 muscle fibers that preferentially run on aerobic pathways for energy. They're small in size, super oxidative, low force production, high resistance to fatigue, having slow contraction speed with high in both mitochondrial density and capillary density. People play high endurance sports like marathon runners or cyclists. They would have more slow twist fibers than the others for their athletic performances. Fast twist fibers, also known as muscle fiber type 2B, on the other hand, are larger in size, very glycolytic, high force production, but low on resistance to fatigue. They have fast contraction speed with low mitochondrial density and blood capillary density. These fibers work very well with the sprinter and weightlifter, for example. In between these two muscle fibers, we have one more fiber type, type 2A. You can think of this as the medium of both. Type 2A is fast twist fiber in nature. Examples for people who tend to have more of these fibers are the swimmer and rower. One interesting thing about this type of fiber is that type 1 and type 2B can induce a shift to become more type 2A-like fiber to meet your demands of doing more intense exercises with longer time under tension. And eventually, you will end up with more type 2A fiber activation in each muscle recruitment. It's a good thing because since type 2A fibers have both oxidative and glycolytic characteristics, they can produce ATP relatively quickly via multiple options of energy pathways. Moreover, type 2A are able to maintain resistance to fatigue at a higher standard compared to type 2B. They are very versatile and adaptive to various exercise intensities and durations. Athletes who are at the top of their games are usually being referred to as hybrid athletes, having more type 2A fibers in their muscle groups to withstand the endurance challenge as well as the intense force they have to produce in their performances. To execute a flawless attempt, it requires a strength and effort to hold their entire weight at one continuous motion from start to finish, just the same as doing bicep curling. As we have learned about the energy metabolism in muscle cells and what types of muscle cells we have, it's time to apply all of this knowledge to build muscles in real time. We need the heart to complete this job. Heart rate response is one of the best connections for you to know approximately where you are at the energy production force during exercising. As exercise intensity increases, heart rate rises to deliver more oxygen and nutrients to the muscles. In contrast, low intensity exercise keeps the heart rate response slower. So let's say you are jogging and your heart rate is about 90 to 110 beats per minute. This means your muscles are mostly using aerobic pathway for energy. If the peak of your aerobic pathway is around 140 to 115 beats per minute, then anything over that meter will likely trigger the muscles to go for anaerobic pathway for faster energy production to meet energy demands. The fast twitch muscle fibers will take over and predominate the force production until all of those cells get too fed up by waste products, or until you stop doing the intense exercise. The heart rate naturally decreases back to lower 115 beats per minute, and the aerobic pathway will be the main energy production force once again. Therefore, one of the best ways to grow muscle is to train both aerobic and anaerobic pathways, pushing both of the production systems to their limits over and over. This will allow the body to become more efficient at what you do and adapt your training with bigger energy production force capacity, and recruiting more type 2A fibers for endurance challenge, while refining type 1 and type 2B fibers. The big picture here, even your heart rate isn't necessarily rise to over 115 beats per minute, you can still recruit fast twitch muscle fibers and keep them at work. Your heart rate will then adjust and follow the pressure you have given. Here are the two main conditions to trigger fast twitch fiber activation besides the initial compulsory activation phase. 1. When a particular regional part of the body demands for energy exceeds the supply of oxygen at that time. 2nd, during high intensity exercise, fast twitch muscle fibers are recruited, which have a limited capacity for aerobic respiration. As a result, they have to rely on anaerobic pathways to generate energy. That means even if you do a deckhand, the agonist muscles, aka the primary muscles for the movement, will have to rely on anaerobic pathways for energy when you increase the time under tension. Your breathing will become more rapid, of course, because your body is demanding more oxygen at this point. But the systems for energy force production in these areas have been switched to anaerobic pathway to get more energy to sustain the movement. If it is pulled up, needless to say, after the phosphagen system is depleted, more areas of muscles will have to keep switching the energy systems back and forth to execute your movements. Remember how the phosphagen system provides us energy just for about the first 15 to 30 seconds max? So it makes sense that time under tension for deckhand or pull up or any other exercise you do should be at least over 30 seconds to kickstart the glycolysis process, in which your cells have to come out and generate energy to sustain on their own. That's where the lateral magic juice is being developed. So basically, your heart rate rises relative to your energy demands, and increasing the duration of a movement will definitely improve the energy production efficiency inside the muscle cells over time. These changes enhance two things. 1. ATP regeneration. Faster ATP production during glycolysis can sustain muscle contraction during high-intensity exercise, delaying fatigue. 2. Reducing metabolic acidosis. Efficient glycolysis can minimize proton accumulation, reducing the development of metabolic acidosis and associated fatigue. In other words, your endurance to that movement has improved by a lot, and you can then focus on muscle hypertrophy phase, which is methods like progressive overload, which can directly improve sarcoplasmic hypertrophy and myofibrillar hypertrophy. Though no matter how much you train, a proper muscle gain is included with proper resting, stretching, and taking care of your heart and overall well-being. Stay hydrated, guys. Catch you next time.